Mats Rosen, and I work as Head of Project and Change Management at DSV Road in Sweden. DSV is a worldwide company in freight forwarding, air and sea, and third-party logistics. But I'm working in Sweden and have been part of the e-freight project. What I want to start with is to show you a short video that we produced within the e-freight project together with the GS1.
In a matter of seconds, consumers make buying decisions about products on retailers' shelves. They expect products to be available when they want them. To meet this expectation, manufacturers, retailers, carriers, freight forwarders, and government agencies, like customs and port authorities, must collaborate closely to get goods to stores in the most efficient way. This requires an agile supply chain with efficient transport and logistic processes, which is enabled by a common language to identify, capture, and share information globally using advanced security mechanisms.
Still, I like to bind the business processes together with the operational processes. And we have two KPIs. One is to reduce our manual resources to 50%, together with an efficiency improvement of up to 10 minutes.
This is where the e-freight framework and the GS1 standards come in. They form a powerful combination that helps companies optimize transport and logistic processes. With GS1 standards, stakeholders know exactly where products are at any point in time along the supply chain. They give stakeholders the needed visibility so that products are available when consumers want them. E-Freight is a project co-funded by the European Commission and freight transport stakeholders in support of the EU transport policy. The e-freight framework has been designed for the paperless exchange of freight information. It is capable of converting message formats, like for instance GS1 standards, to make them suitable for any company engaged in a multimodal freight transport and logistics. E-freight also provides a simple, secure mechanism for information exchange in freight transport and logistics called access points. Today, businesses need to make multiple, separate connections to share information electronically. With the e-freight access points, companies connect to a single access point to simply and clearly share information with all supply chain partners. The system is as easy as sending an email, but with added security. Here's how DSV Road, a freight forwarder, and Stena Line, an international short sea operator, are both using e-freight and GS1 standards for more efficient transport. DSV receives transport instructions from a number of shippers, one being from SCA. It combines these shipments into one consignment to be transported via road, then ferry, and then back on the road. DSV easily books capacity with Stena Line by sending a GS1 transport instruction message. Stena Line's booking system receives the GS1 transport instruction, automatically processes the request for space, and an immediate response is sent back to DSV. It's in real time and it's easy. DSV selects a road carrier to get the shipment to the port by sending a GS1 message converted to e-freight via the access point. This message is now identified by a Stena Line booking number. The road carrier adds driver and truck IDs along with the estimated time of arrival to the Stena Line booking. The terminal is now prepared for automatic check-in when they arrive. At the same time, warehouse shippers prepare the products for loading. With the GS1 logistics label in place, the shipment's path from origin to destination will be tracked, even when the shipment is combined with others. The cargo is scanned to ensure proper loading, and a status message is sent to DSV. And the truck is soon on its way to the port. truck enters the port terminal without delay and delivers the trailer. And a status message confirming arrival is sent to DSV Road. After security checks, the trailer is loaded onto the ferry. A status message is then sent to DSV. The ferry sets sail. When crossing borders, reporting to authorities is easily done via the common reporting schema message developed by eFreight. Upon arrival, the trailer is collated by the German road carrier and a status message is sent to DSV. The goods are on their way to the final destination. Now, consumers will find the products they want when they need them. Collaboration between GS1 and eFreight has improved efficiency and visibility.
When we interact with many different business partners like customers, ferry operators, train operators, terminals and hauliers, we need standards, and the new messages from GS1 makes it possible for us to use one single message when we interact with every of those business partners.
DSV Stena is simplifying the connections with eFreight and gain visibility of the shipments with GS1 standards for optimized transport and logistics.
The power of the GS1 standards, combined with eFreight framework and access points, supplies optimal connectivity, seamless interoperability, and real-time visibility. A winning combination for DSV and Stena Line.
Okay, that was the video about one of the business cases in the different project. Now I will give some short comments and lessons learned, what we have found out on the outcomes from the eFreight project and what we are doing right now at DSV in Sweden and what we are looking forward to by using those outcomes. We started with EDIFACT and EDI in Sweden in the end of 1990s and the connected customers. Then we did something with Stena Line, with sending booking messages for doing the ferry bookings, but it wasn't common. It was special between us and Stena, and we need to do it one time with another ferry operator and a third operator, and it takes a lot of time and costs a lot of money, so we needed standards. Then we had the transport instructions work for GS1, starting reading their new XML messages, where we took part from DSV's point of view. And more or less at the same time, the eFreight project come on, and we were a partner within the eFreight project, together with Stena Line. As in the movie, we have, as a freight forwarder, we have many different stakeholders to integrate and change data with. We have our customers, we have ferry operators, train operators that are producing what we have sold to our customers. We have terminals, cross-docking centers, we have our subcontractors' vehicles to share information with, and we have the authorities. Before eFreight, we did and have thousands of different connections, mappings, different messages, different formats, different protocols. And that is, as I said, very costly, and the time to market is too long in 2030. We need more standards and we need faster time to market when we have changes and we get new customers and we have new ferry operators, new subcontractors and things like that. So that was what we wanted from the e-freight. This is the model from the business case together with Stena Line, where we do bookings. You saw everything in the video, so I will walk through this picture. What we more did in DSB, we built a new site in the southern part of Sweden. We closed down 2 of our biggest sites and started and moved into this one the 1st of January this year, and it's about 100,000 square meters for reloading and warehousing and an office. We have about 700 vehicles entering the site every day. And there we started to build a new job management and terminal planning system. And this system is internal between our other booking and TMS systems, but it's based on the e-freight messages and the e-freight different communication platforms. So we have tried this in extent to the other thing was Stena Line, and it works. We have the GS1 messages and other messages. Normally we talk about subsets from big messages, but what we're talking about different guidelines from one single message to transport instruction. And it's the same schema that is used, but we use different guidelines depending on which stakeholder we want to communicate with. If it's customers, ferry operators, our vehicles and subcontractors, or terminals. But it's the same message, but used in a different way, instead of using, as we did before, we had different subsets of the 85 messages. The message is maybe complex, but it's not complicated. And it's scalable, and we have tried out it now in different stages. You heard this is in the video. Communication, it's hard. But why should it be harder to communicate between systems than sending an email? I'm sending emails to my friends, my family, my colleagues and customers. I never think about, I will send a mail to Fleur. Which format, which protocol should I use? I just put in the address, and the information in the message is of course different. But I never ever think about protocols and formats. That was what we tried to find out within the e-freight access points. The e-freight access point is based on Pepper. The e-freight access point has attached 3 more services on the normal Pepper standard. Push mechanism that can force messages out from the Pepper mailboxes. So we nearly come to a real-time communication. It's asynchronous communication, but it's really fast. We have made profiles to make it easier to publish what I can send and receive, what kind of messages or processes. And we have built in the e-freight access point a cache mechanism of the addresses that increases the speed for a round trip within the access point of the Pepper system to exchange data between different partners. We talked about the e-freight messages, we talked about GS1 messages, and the e-freight access point gives, you connect once and you communicate with it. It can be different other standards. Standards are very good, and we need standards. Standards are so good that everybody should have their own. then we need to communicate. And we can publish different profiles on the it. It's there and it works. I need to set up my backend system, my business processes once. And then I can start communicating with all my different stakeholders. This is what we have found out from the e-freight access point system. And because of it's based on the PEPL, if you don't have e-freight access points, you have a PEPL, it's possible to communicate with those stakeholders as well. It needs a little bit more configuration tests maybe, but it is in the same communication system. What we are doing more out after the e-freight project. At DSV we have more than Stena Line as a ferry project. We are now trying to make a connection with the Viking Line. Viking Line didn't have any booking system automated from system to system point of view. And they decided to go for the e-freight model. And we are now running tests, and we will go live latest the 1st of January. And we are testing what this is now when we reuse what we found out in the e-freight with messages and communication. And we can find that we will save, the cost is at least 6% lower. Time to market and implementation costs when we reuse the messages and the communication protocols. Interoperability, we didn't find any railway train operators within the e-freight project, but we have at DSV now found a train operator working in Europe that we are starting a project, and we are now developing communication and booking setup based on what we found out and based on what we came out from the e-freight project, with the same messages that we are using with the ferry operators. And then next is that we need to start new customers and new carriers and subcontractors to use the outcome from e-freight messages and the e-freight platform. After that, what next? How can we use the outcomes of this more, and what we have heard this morning about visibility, about different shared data, private and public data? I think that we want to make it easier. We have lots of subcontractors, and we need to make the connection, and those are the small enterprises. A carrier having 2-3 vehicles. We are trying to establish communication with the truck manufacturers, because they have fleet management systems. Volvo has there, Scania has, Mercedes has. And we need to see if we can connect to them, and then our subcontractor, if they are running a Volvo, they can just subscribe for their fleet management, and then they can get orders from DSV via that system. And what more, we can get data back from the vehicle. And that's the next thing we are looking into, and that is environmental data. Carbon footprint and different engine types, because the requirements from the customers is increasing, that we need to report back environmental data. That gives us possibility to get this from the vehicles in the same way. And the third thing, what we are looking into now, is to get this data visible, private data, public data. We are looking into the EPCIS repository thing to store all events, and then make it possible on a standardized way to share it with our different stakeholders, and maybe some data can be public as well. But we want to start with it for us, because I think that the transport industry is a low margin, and we have competitors, we are competing, and I think it's we are a little bit afraid of sharing all data public and broadcast it, because there are business in that as well. But I think